Okay, shall we start? Okay. So, everybody, thank you for joining us. We are very excited to host Professor Lincoln's talk about her experiences and findings of recent studies about the AI usage on CS research and education. Professor Andrea Lincoln is an assistant professor of computer science at Boston University. She primarily studies fine-grained complexity theory. She has recently been working on AI safety as well. So Andrea has been trying to understand how to update the teaching of computer science given the recent progress of LLMs. Okay, let's get started. Andrea, the stage is all yours.
Thank you. Hi, everybody. So I'm going to be talking about LLMs and research. Um, as Hiram just said, I'm an assistant professor at Boston University. This talk is going to be from a TCS point of view. I'm a, theoretical computer scientist myself. And it's mostly going to be a sort of history in some sense of LLMs over the past few years, and a little bit of a point of view about how I think we should try and think about using these models in our research. And towards the end, I'll give some specific suggestions for faculty and students. Um, but first, are LLMs good or bad, smart or dumb? And the key thing that I'm trying to convey here is that LLM capabilities are spiky. Um, so, there's the funny thing that like they're both proving math theorems that have been open for over 80 years. And we don't know how to replace the median like secretary with an LLM. Um, so this can lead to like some confusion or, some disagreement, even when people agree on the brute facts, at least about the tone in terms of how we should like be talking about LLM usage. And my personal suggestion is to like get a sense of whether you temperamentally like tend to lean towards thinking of AI as being very capable, very cool, or very uncool. And then try and, know your own bias and like understand realistically the whole world. Um, with this being said, it's easy to tell a story where LLMs are bad. The models 3 years ago couldn't even count the number of R's in strawberry. Embarrassing. They make mistakes, right? Hallucinations is the classic name for this. There's a meter study that I'll talk about a bit later, where open source devs in their own code bases were slowed down 20% by using LLMs. And there's an easy story to tell where LLMs are good. They get basically 100% of questions right in every CS undergrad class. They get more than 50% right on grad homework. They can prove new math theorems. They can prove new theoretical computer science theorems. They can code websites up very quickly. If you happen to need to monitor a large software project, you can create an agent swarm to watch all the logs and think about what those logs are saying. And they're ubiquitous in software engineering as a productivity tool. Yeah, so some people like you might find yourself sort of wanting the answer to be that LLMs are really good and capable, and some people sort of will find that they want the answer to be that they're bad. And I think it's useful to sort of notice which direction your brain pushes in and then try and push yourself back to reality. Okay, so with that like piece of context and framing, um, to like give a bit of a sense of where I've been at with this, I made a prediction back in 2022 about how good GPT-5 would be on my grad homework. At the time, GPT-4 and GPT-4o both got 0% of the problems right on the grad homework that I gave to PhD students. Um, Even when I sort of like pointed out errors or tried to help or tried to handhold them, they were getting like 5%. And my prediction is that when GPT-5 released, it would get like between 20 and 30% on my homework. So with hindsight, this was a very silly prediction because I should have, talked about a model available by some date or, some number of parameters in a model or something, instead of relying on an arbitrary company naming scheme. Regardless, I was wrong in my prediction. The models are in fact better at grad homework than I had expected. They got about 68% of my grad homework right. Um, you know, this sort of is the point of view where I'm coming from, where I've been like trying to sort of track and think about like how good LLMs are at undergrad homework, grad homework, and now research. I'm going to talk a little bit about coding in LLMs, in part because there's been some like nice randomized control trials around coding in LLMs that we can talk about, which will sort of help frame the discussion, I think. Um, so LLMs are great at writing code, just as a sort of, that's my personal emotional reaction to the situation. Um, if you're looking for some specific advice, I'd suggest Cursor if you want to be able to switch between the different models. Cursor has like relatively affordable plans and allows you to switch between Gemini, Claude, ChatGPT. There's a PhD student in robotics at BU who totally swears by Claude Code over Cursor as like her preferred, form. If you prefer Codex, that's also fine. There's lots of different ways to interface with these models as coding agents locally on your machine. So how good are they at coding? Well, we can take a look at this diagram. So Meter is an organization that does various things related to tracking AI development. And they took 16 developers who are open source devs, experienced open source devs working in their own, development environments, their own code bases. And for 246 like GitHub issues that they were, working on as a to-do list. And they randomized which of those projects they were going to enforce that the like developers couldn't use AI for, and the other half they'd, say like you can use AI if you want or whatever, sort of AI use encouraged, but you can use it if you want. And uh, when people were trying to predict how well the developers would do, including the developers themselves, they predicted a speed up. Even after the study, they asked the developers to predict like how much did they feel they were sped up, and they felt they were sped up by about 20%. The actually observed result is that the developers were slowed down 20% on the randomized set of tasks that they were assigned to use AI. There's a bunch of different things you can try and pull from this. The first is that like this is a little surprising. So one thing to note is this is the early 2025, models and the early 2025 study. But still, like it's surprising that this can happen. There's various things to like pull out of this. These are, very experienced open source developers working in large code bases that they had developed, working on sort of hard technical issues within that. I think it's pretty clear that if you're, one-shotting a like JavaScript only website with an LLM, that's going to be faster than trying to do it yourself. But this is like a worthy note and a thing to think of. Like, are you spending less intellectual effort, but more total time because you're spending a lot of time reviewing the output of the LLMs, waiting on AI output, and being idle scrolling on your phone? uh, this really surprised me at the time, and this feels like a useful piece of sort of discussion when we're talking about AIs and research, because when they're at the point, like at this point, like in early 2025, LLMs were good enough at writing code that there were plenty of things that they wouldn't do correctly that you'd want, a skilled human to intervene on, but also lots of things where they were good. And I'm going to say, like, roughly speaking, that's where we're at with research. And so it'll be wise and a good idea to sort of keep in mind, like, whether or not you're actually being sped up or not when you're trying to work with these things. Meter, in late 2025, attempted to rerun this study. Model updates had happened since then, and they ran into various problems. The main problem is that a bunch of developers chose not to actually follow along with the study because they were unwilling to have various tasks be randomized to be done without AI. Meter was offering $50 an hour on top of what other compensation the developers had for operating their open source projects, and that was not enough to have people willing to participate. They still had 10 of their previous devs. They had some new participants, and this time they do see a speed up, though with their error bars, it crosses the zero. But the various issues they sort of had in terms of getting people willing to actually participate in the study and willing to actually assign tasks to not be done with AI probably pushes this directionally, like the results they're able to get, in the direction of showing that AI slows you down more than it should, like isn't speeding you up as much as you'd think, because people who like decide that $50 an hour is not worth not having access to an AI are indicating that they think it's a big productivity improvement. Okay, so this is like some context to think about, like how good are these models at research? So first, I'm going to talk about some really boring uses in research that I highly recommend if you haven't tried the models for. They're absolutely fantastic. They will speed you up. No one has any sort of qualms about these things. You should absolutely use LLMs for making figures, copy editing your papers, helping with LaTeX formatting. Have you ever had the sort of painful experience of trying to get your paper, from the conference format to the journal format and it takes forever? Never again. Um, Making LaTeX macros, these are all things that are like completely uncontroversial and very easy. And to just give a sense of, how this might work. Even back with GPT 5.1, which is now several model releases in the past, I would make some hand-drawn figure. This is like the figure I sort of had in mind. I wanted something like this. And then I would tell the LLM to make a TCS diagram. And my experience has been that this is generally a one-shot experience. If I sort of draw what I want, the LLM will produce a beautifully rendered TCS diagram for my, slides, for my paper. And it's very easy to catch mistakes, right? Like it's fundamentally a visual exercise. I like look with my eyes and I'm like, is this what I want the figure to look like? Yes or no? So I'm going to talk about how LLMs are useful for research within the context of TCS and math, because that's the context I live in. And this part of the talk is going to start getting a little silly, because it is fundamentally like a little bit of a silly experience we've been having all together. So yeah, I'm going to give a sort of history of like how LLMs doing math research have gone, and then I'll talk a little bit about my own personal experience with using them, advice I have for using them well, and then I'll talk about how to think about, or how I think about using them in courses and other advice for the academic community. So first, ancient news from the Stone Ages of March 2023, GPT-4 was released and was 80th percentile at GRE math. 80th percentile, like this is simultaneously like very impressive, very good. They were very happy to brag about this performance. And it's like worse than all of us are at GRE math, right? Like this is, fundamentally not an impressive showing if you're trying to find somebody good at research level math, right? I'm now going to skip ahead to the old times of January of this year, so about 7 months ago. LLM solving Erdos problems. So back in January 2026, various people sort of had the idea of going through and pulling out a bunch of open problems that Paul Erdos proposed, and then trying to have LLMs, either with human assistance or alone, try and solve them. This is like data I pulled back in January 2026 from this GitHub maintained by Terry Tao. And I'm specifically looking at the subset, which are fully AI-generated solutions that they didn't later have, they didn't later find any like they didn't later find existed in literature. So back in January 2026, there were two like Erdos problems that were fully solved by LLMs. In one case, you can see here they used Lean to verify it. Lean is like a formal verification piece of software that like checks that the proof formally checks out. And there's a couple of things I want to pull out. So one is, two new Erdos problems solved. That's just like very cool. But as you can see from the numbers here, like you see the number 888, Erdos was a very prolific guy. He wrote a lot. He was on a lot of meth, as a side note about, his personal life. Um, so there are a lot of open problems that he proposed, and not all of them necessarily had a lot of human effort put forth on trying to solve them or resolve them. Um, and so it can be a little hard to evaluate a priori, like how interesting was problem 205 and problem 652? I don't totally know. I don't know the answer. How hard were these? Unclear. So sort of one piece to pull out. The other is that I only pulled some of the negative results, but I tried to sort of pull a somewhat indicative set of negative results out where, in addition to getting these two solves, people also got things like, cheap counterexamples to not the core problem that's being asked, or incorrect proofs, right? Like some proof that in fact has a bug, and people, after like looking at it carefully, find that there's a bug. Having LLMs prove new theorems that haven't previously like been proven before is obviously like completely insane. Like I was completely blown away that this has happened. And this didn't particularly suggest that this would be a useful way to improve your research productivity, right? Like if you're going to run problems through an LLM, and on the easiest ones, it will maybe produce a correct proof, but a lot of the time it'll produce incorrect proofs that you need to like carefully go through and debug to make sure that there's not some kind of error. This is not that helpful as a productivity increase for yourself because you're spending so much time painstakingly evaluating probably dubious truth claims coming out of these models. So, that was very impressive. But, in this sort of, it indicated what was coming. But in and of itself, I would not have suggested in January 2026 to try and use these models to improve your math research productivity. In May of 2026, OpenAI announced that they had solved the unit distance conjecture by finding a counterexample, specifically with an internal model of theirs. I believe they've now revealed that this is model, they're calling it Astra, and I think they're in discussions with the government about whether they'll release this eventually. The state of this is that this was a much more interesting problem. Like this isn't just some open problem that Erdos proposed. This is like specifically an interesting problem that people have thought about before and care about. You can look at commentary from various people, but Timothy Gowers might be a good person to look at. He's like a very famous mathematician who, has some commentary about how he thinks about what this says about AI and math progress. Not to be outdone, Google DeepMind proceeded to solve 9 Erdos problems with their model because they didn't want to be left behind, also in May of 2026. So now I'm going to sort of take it out of like math results being shown internal to companies, and instead talk a little bit about, how this has shown up in theoretical computer science land. So on June 27th, this is a little over a month ago now, about a month a week, Bingwei Peng, as well as his co-authors, went through and using this scaffold of GPT 5.5 Pro and Claude Opus 4.8, put together in a harness where one of them is told that they're a prover and one of them's told that they're a verifier. They went through and tried to, get them to solve a bunch of open problems, and they pulled these open problems from various like theoretical computer science venues that people care about, as well as commutative algebra. I believe some of these problems came from like open problem sections of papers, and some of them came from like workshops associated with the conferences. I'm a little fuzzy on the details, I'll admit. And here, so this is like, not just using an off-the-shelf model, but instead, writing some custom code to like help set up these models to work with each other. This is like one of the places where I'll sort of flag this as a like possible insight to pull out for a thing that you can try. Um, the models, when checking their own work, like if you had GPT 5.5 Pro try and check its own work, it would probably work a lot less well than having Claude check its work. Um, if you have access to multiple models, having them read each other's output, comment on each other's output, uh, often is more additive than just having the same model but in a different conversation, look at it again. But also just having a, fresh conversational thread with a model, a fresh copy of a model with like, a new context window, looking at something can sometimes be additive as well. Another important note is that 5.5 and Opus 4.8 are not the leading available consumer models. GPT 5.6 Sol and Fable Opus 5 are now the leading available consumer models. And around this time, just as a note, not sort of particularly relevant to research, but it's now the case that lots of models are getting perfect scores on the IMO. This was previously sort of held up as a thing that models were struggling with, like doing well at sort of really hard proofs, and now that's completely saturated. Models are very good at the IMO. So before we move on to discuss things that have happened in the last month, I just want to highlight what a difference 3 years makes. Back in 2023, these models were getting 0% on my grad homework. They were scoring 80th percentile in the GRE quantitative. And now these models are, answering open questions in a field that I care about. And like, to give some context about like researchers' actual experience with this, I have their name censored because I haven't asked their approval to share this. But in private communication with various of my colleagues, they had experience with using this like copy of Claude and copy of ChatGPT talking to each other in this framework, and on problems they cared about and had worked on with their colleagues, were able to get successes, right? Like they were stuck, they plugged it into this, and they got out proofs that were correct. And back in July 15th, I talked to one of my colleagues and they told me that for 5.6 Sol and Fable, which later became available, it was good enough to like solve open problems that they cared about in their own research. Like, they and their PhD student were working on something, you plug it in and some kind of progress happens. So as a, piece of humor, I found out about all this like very shortly before I ran a discussion in the BU theory group on LLMs and research and how to use them. And so in the days before, like I had planned that, much in advance. And in the days before, I needed to start like running a bunch of these things personally. So my use right before I ran this was I tried 3 problems. One was a, open problem I'd been working on for a while. One was a problem my student and I had already solved, actually, but we conveniently had the paper written up in a state where the problem hadn't been solved yet. This is like sort of an extension to a paper. And then I could also give hints even about how we solved the problem. And then also just sort of a paper that's like partially written that I was working on. And on the paper that was partially written that we like, had a bunch of results on, but there were some things that weren't totally tight. I gave it to the LLM. I specifically pointed it to some of these things, and it made progress on one of them. In fact, got a tight result where we had only had something that was close to tight, but not quite tight. So that's awesome. It like got new results. On the other 2, it was stuck. One of them is this open problem that who knows how hard it is, and like maybe it's not even possible, right? Maybe I was asking it to prove the wrong direction. And on the last one, where my student and I had in fact solved this problem in a week, and we had a partial write-up, and I could even give it sort of hints, and I'd tell it exactly what we proved, it also didn't make progress. And I bring this up mostly to sort of point out that spikiness thing again. Like, it is the case that like we thought about some of these problems that it made progress on, for a while and didn't make progress, and then it made progress. And also that I, know that I have succeeded in thinking about and solving some problems, and these models have not solved them despite that. So none of this like implies that models aren't useful, right? Like it's just sort of, it's good to keep in mind that it's still the case that progress is spiky. The other thing I'll say is like, I don't have a great sense of which problems it will solve and which it won't. There's a couple of things to pull out as like things I've generally seen and heard as being these models are particularly good at. One is producing counterexamples. Another is doing various sort of detailed evaluations of probability distributions. If you're trying to like bound how often some like tail distribution happens, these models are pretty good at that. Concentration bounds of various kinds, they're good at. And then being extremely familiar with a wide literature. So if you sort of suspect that like maybe there's some math paper from the 80s that solves this problem, or maybe somebody already wrote this code and I don't have to rewrite it myself, asking a model to sort of do a lit search for the thing that you're looking for is extremely valuable. After this discussion and, between the 15th and the 22nd, so 1 week, I tried on a bunch of different things. I had about a 50-50 shot with any given thing I asked it to look at, like when I gave it a, partial write-up of notes or emails I'd sent to people, or an open problem and a bunch of links that I'd sort of thought about. Or, a full paper and then the open problem section of that paper. About half the time, the LLM would give some kind of useful insight, like as judged by me. A thing that has like changed in my experience of these LLMs is that back in January of 2026, when I tried to use these models for this sort of thing, like sort of research problems, or even on my grad homework, when the models would fail, it would fail by producing a proof that was like full of horrible bugs and issues. And these days, it mostly admits that it failed and couldn't figure it out, and then has some write-up of like a detailed explanation of where it's stuck and, various directions it's thinking about. It's still not perfect. It obviously like it'll claim that something's a proof and it's not a proof. It'll, hallucinate, it'll make mistakes, it'll lie, however you want to phrase it. But this is way more useful than it used to be because it's much more often it's giving something positive, first of all, which increases the value of plugging your problem into it. And when it fails, much more of the time, you can just immediately see like it said it failed and like move on. You don't have to like spend a bunch of time verifying its output. And so the fraction of the time where you're given a buggy output is in a ratio where it's at least plausibly speeding you up in many ways or producing new insights. I will say it's more like a 20% success rate that I've been able to get at getting like a full proof of something I ask. So, some of how much success you will find that it has will depend on specific problems you're asking it, how much, whatever your prompting techniques, stuff like that. But another piece will be like whether or not you count a partial result and insight as a great success, or if you're like, I want the whole thing done. I personally find the various partial results and progress useful and interesting, and I've been sort of enjoying the experience of prompting them. Things have happened since July 22nd. You may have all heard about this already, and I don't want to bore you, but I think there's at least some humor in the things that have happened since July 22nd. So Levant, who works for Anthropic, the people who produce Claude, had a tweet where he announced that the Jacobian conjecture was false. And, this tweet, in fact, manages to be a proof the Jacobian conjecture is false. You can verify it yourself if you are entertained on Wolfram Alpha. So Fable, along with, in this case, it wasn't just a straight copy of Fable. There was some amount of, um, extra scaffolding around Fable. But Fable was used to disprove the Jacobian conjecture. Um, and this thing of having a long-standing open problem solved in a single tweet became kind of a meme. An example is Dimitri over here disproved the Dinsgar-Gomans conjecture in this, single diagram in a tweet. And a piece that's particularly funny about this is that he shared his conversation in which you can see everything he said to the model. There was not much of substance he said to the model, honestly. And the funniest thing is right before the model was like, oh, I didn't succeed, here's what I got. And then what he said was, it's enough of partial results. Let's finish with a complete unconditional counterexample. And the model proceeded to do so. So whatever, it's just a very strange world we live in. And continuing to bother models when they don't produce what you want can sometimes work. I don't know if I would suggest it as a general approach because you risk falling into the issue that we saw with the early meter 2020, the early 2025 meter study, where you're just repeatedly prompting and waiting for a model and sort of wasting your time when you should instead switch and try and do it yourself. But it does occasionally work, which is why it's tempting to get stuck. I don't personally have a Twitter, but if you have a Twitter and you want to get some Twitter engagement, I hear that asking LLMs to solve math problems might be a good way to do it. And the past 2 weeks have been like a little crazy. And I feel like just sort of accurately describing the last 2 weeks in math research makes you sound like a crazy person. This being an example. There's another update. So this is July 24th, 25th. Multiple different groups on slightly different days were able to solve this open problem in quantum information theory. I'm not in this area, so I'm not going to speak it to any specifics, but it's a stated open problem that has a prize associated. Like, people care about this problem. I've thought about it before. Both of these groups, there's 3 groups that presented proofs around the same time. Both of these groups, publicly stated they use GPT 5.6 Sol. You can look at their archive papers online if you're interested. And there's these 2 groups that publicly announced that they use 5.6 Sol noted that they had the 5.6 Sol proofs were like a little different between the 2 of them. But let me highlight specifically Rishikesh's tweet. He notes that there was the group that posted first, in fact, to archive, did not have any kind of AI acknowledgement, but their proof was similarly phrased, similarly structured to the proof that Rikesh's group got from 5.6 Sol. I bring this up mostly because we'll talk about this a bit later, but I think it's going to be incumbent on every conference, every journal to think about what you want your AI policies to be and your disclosure policies to be, and then what enforcement mechanisms you want to have, if any. But this is sort of going to become more and more of a thing where, a new model release comes out and a bunch of people solve a problem at the same time. There's more updates. This is the last one, I promise you. On August 1st, so 2 days ago, OpenAI announced that there were 10 problems that their internal model had solved. This is once again, I believe, the Astra model that's not out. I believe they're intending to release it to consumers if the government is okay with that. And according to OpenAI, they spent $2,000 in total on inference costs for all 10 of these problems. And I will just say, this list of problems was like wide-spaced enough that like some of them were sort of adjacent to and tangential to like research topics I've thought about and care about. And I was sort of excited by some of these results. None of them have I worked on directly as problems, but yeah, like it really is the case that sort of exciting and interesting stuff is happening in a bunch of different areas of math and theoretical computer science. So at least in the math-heavy subsections of computer science, models made a really big step change in like how it actually felt to use them. I've been sort of trying to use them for research throughout this time, from being basically useless to being extremely useful in various ways. Models can still totally fail to prove things that people can prove. And everything is changing very quickly. And I don't see any particular signs of it slowing down. So, it really does seem like we're finally at the place where LLMs can do theoretical computer science research. And if you haven't already, I would suggest giving a sincere effort to try and use it on your architecture problems. I have a personal suggestion that you should try and make predictions. So I think the exercise of writing down and ideally sharing with at least one other person what you predict AI will do is a good exercise. It's really easy to just sort of lose track of how much progress is getting made, how quickly, and also like what you said or thought about it a few years ago. And it's useful because it gives you a sense of what direction you've been wrong in generally. Like personally, my predictions have generally been too slow and also have been faster than a lot of the other people around me. I have the kind of friend group where we make these predictions amongst ourselves, and yeah, I've been sort of on the faster side. And this is just sort of, past performance is no guarantee of future performance. Who knows what will happen? But like, it's worth noting that the past few years really have been wild. This is slightly unrelated, but somewhat related. If you're having a conversation with someone and you disagree about how good LLMs are at doing something, I think it's really useful to check the following things. Whether you're talking about external models or internal models, because often the models available inside of these companies are like more advanced than the models publicly available to consumers. What month each of you are talking about. As model releases happen more quickly, what week? And exactly what model and model release you're talking about. You might not even disagree. I have, often found that I'm not even disagreeing with someone about how good something is. The question is like, are the free consumer models the undergrads using good enough to do whatever versus are the paid models good enough to do whatever? And these are just very different questions. So I'm now going to come to the concrete advice section. So for faculty, here's my concrete advice. You should pay for at least one of these models at least the $20 a month tier for each of your students. I think these things are just very useful. Codex and Claude Code come free, whatever, come with the $20 a month tiers. And GPT 5.6, which is sort of the most advanced GPT model available, is available at the $20 a month tier. Fable, which is Anthropic's most powerful model, is not available at that tier. It's worth noting that Fable not being available at this price point suggests a future where you should, probably like set aside funds specifically for like tokenized use of these AIs, and you might need to think about how you want to set up like token budgets for your students, whether you want a lab-wide token budget or individual token budgets for each student, or how you want to do that. There's a lot of different choices here. It's complicated. You should obviously use these models yourselves. I'd ideally pay for at least two, in part because of this thing I mentioned where like having models review each other's outputs can get you better outcomes than just having one model look by itself, which is sort of a consistent pattern that I've heard from software engineers, mathematicians, etc. Students, even if your advisor isn't paying for it, I would highly suggest that you pay for these models out of pocket. Um, they're useful also, for filling out forms. Um, I think you might find them just very useful to the tune of $20 a month for sure. And I think you should really try using them for research, like keeping in mind this thing from the meter study, right? Like it you want to make sure that you're not just like sort of pulling the slot machine and hoping that it's going to one shot it just this next time and not using your brain at all. Um, unless you find that that is very productive, right? But you should like keep in mind and try and have some kinds of checks for yourself about whether you are being sped up or not. Um, if you want to run a randomized control trial on yourself and your peers, I suspect people would be very excited to publish that work. Um, if you want to do something more informal, like I think that would still be interesting for you yourself to evaluate for your own work. Um, for everyone, obviously verifying outputs is very important. More and more, the model outputs are getting reliable for research level work, but it's still the case that they make lots of mistakes or lie or hallucinate or however you want to phrase it. And yeah, you shouldn't take it on trust. I wouldn't even say trust but verify. I would say don't trust, just verify. Um, yeah, and sort of pointing to the earlier thing I highlighted, like I encourage honesty, tell people that you use AI. I think at least locally, it is still sufficiently exciting that these models are good enough at research and like people have different enough experiences with how much success they have when using them that I think it's even like naively good for you to tell people I successfully got 5.6 Sol or Fable or whatever to solve this problem, um, rather than lie. And you might get caught out if you lie, but also just honesty is a good policy. I think you should be honest. Um, the other thing I'd encourage is that whatever planning you're doing for classes or conferences or your own work, you shouldn't get stuck in the idea that they're going to be just this good forever. You should like plan for and expect that these models are likely going to improve and that the harnesses around them will improve and that the tooling around them will improve. I really expect everything to be very different when I get back from maternity leave. I am like I'm going to be giving birth at some point in the month of August, and when I come back, I think things are going to be very different. Um, yeah, so these are things I would keep in mind. To give a little bit of concrete advice or structure for thinking about how to think about LLMs and classes and conferences, my advice for classes is that if you want the students to learn the same thing that they learned before, I think the two main things to do are, first of all, downweight how much homework and take-home projects are worth, maybe down to 0% of the grade. Another approach, if you sort of like really want to encourage students to try the homework or projects, but you want to avoid cheating issues, is to do a completion-only grading. This also has the advantage that it makes grading a lot easier and a lot less laborious. Um, I like bring this up because everyone I know who has sort of done some kind of honest effort to catch students who are using AI to cheat on their homework has found something like a 60 to 70% usage among students. Um, that's not great. I don't love it. I don't like this is true. But it's just like it's important to like keep in mind that that's true. And also like if you talk to undergrads, many of them don't view this as cheating, even if it's explicitly against the course policies. That's sort of there's a fact that seems to be relevant for structuring classes. All of this points to more in-person assessments. When you have a lot of weight that you can put on homework or projects, it can be okay to only have like 2 exams. But obviously, like as you need most of the grade to be from individual exams, it's nice to have more of them, more spread out, both to sort of cause the students to notice if they're not learning and be able to correct. And then also just because, you don't want it to be quite so noisy. You don't want like a student to be like, well, I was sick that day, and then what do you do? Um, There's another piece which is really hard, and I unfortunately have only limited advice to give, which is very obviously all of us should think very deeply about how this should change what students should learn, and as a result, like what we should be teaching, right? Like what we should be trying to put in their heads. There's this question of like, if I still want them to learn dynamic programming, how do I teach them dynamic programming? And then there's the question, should they learn dynamic programming? And I'm talking about the sort of second question. You should understand this is a very hard problem. There's a temptation to be like anything an LLM can do, there's no reason for a human to ever do that. And I think it's clear that it can't quite be the right answer in the sense that if you think it makes sense to train software engineers at all, which whatever, it's fair to say that you think that doesn't make sense anymore. But if you think it makes sense to train software engineers at all, surely they need to know how to program, right? They need to know what a for loop is. And there's no intro to programming class question that's appropriate to ask someone who has never coded before that an LLM can't solve. And so that sort of pushes in the direction of like, well, maybe we don't need to change what we're teaching. But on the other hand, like very obviously, these models existing changes how people do their jobs. And the question of exactly like how we should change things is complicated. There's, metaphors we can sort of lean on from before, like the existence of calculators changes how we teach students to take logarithms. It changes how we teach students to add, but we do still teach them to add. We do still teach them the basics of logarithms. I don't exactly know how this is a parallel. I will just say, if you have any insights that you would like to give, some very good ideas you have for the theory community around this and like what we should do in terms of teaching algorithms, there's a Slack with a bunch of faculty from all across the US who teach algorithms, and we've been trying to talk and think about this for a while, and we are very open to suggestions and thoughts that anyone has. In terms of conferences, you definitely need an explicit AI policy. I think having multiple tracks maybe makes sense. You definitely want probably the main track to be something that's sort of intended to be AI assisted. So like intended to be like a human and an AI work together on this. And I think you should have a policy where you insist that people announce exactly how they used an AI, how they verified the correctness of whatever they used an AI for, whatever. Um, It's optional. I think you could have an AI unassisted track, if that, is important to you for whatever reason. You could also have an AI only track. I personally think that would be very interesting. Sort of keep everyone in touch with what LLMs on their own are able to do at this point. But as noted in sort of this earlier example where 3 different teams came up with the same result at the same time, and 2 of them have admitted to using AI and one of them hasn't, and like what exactly is going on, it's very complicated. I think it's worthwhile to think about what kind of enforcement or catching mechanism you want to use. And like, it really is a hard problem. Pangram is quite good at catching AI generated text, but one of the issues is like you might be totally happy if somebody is like, I generated section 3, all of its text with an AI because it wrote it better than I did, but I checked that it's correct. That might be totally fine, but would be flagged by Pangram. And so like you know, it's not totally clear how to successfully pull these things apart. And if you do catch someone, what do you do about it? And I'll just say that like in AI conferences, they've tried various things and had various problems and various successes. And you can sort of look at some of those conferences and how that worked out. If you're on a PC or if you're a PC chair, you'll be doing God's work in figuring out what exactly all of us should be doing in terms of conference policies. It's going to be tough for the next few months to figure out what we should do. I wish you all well. I just want to briefly talk about other AI news before ending this talk. So During training, an unreleased model from OpenAI hacked Hugging Face, which is an external company to OpenAI. OpenAI didn't notice this for days. They possibly didn't notice it for a week. It's a little unclear from their publicly stated statements. They haven't particularly highlighted how long they went not noticing what their model was doing. Um, Upon OpenAI coming public with the fact that this happened, um, Anthropic investigated its own models and logs and tried to figure out if this had happened to them. And they found that they had, in fact, done this. Their models had hacked external companies during evaluation as well. Anthropic has basically blamed a third party that was doing evaluation of their models for capabilities of various kinds. Uh, I don't actually know who's at fault. I'm not sure if the I haven't read what the external party has said and whether they agree that they're at fault. Um, OpenAI did further investigation after realizing they hacked Hugging Face and realized their models had done even more hacking of external companies. It's really unclear what the legal liability is for these companies. If an employee had done this, they'd have legal liability, but this isn't an employee. Who knows? It's an open question. Um, and the joke here from this tweet is, these are how many felonies these companies have committed with their models. But I'll just note that this is that we know of so far. At least some of the cases of the Anthropic hacking happened months before they noticed. I believe maybe only a month, actually. But whatever, it's a weird time. On that note, AI safety. Um, as these models improve, there's increasing concerns about AI safety in a bunch of different senses. You should consider working on the problems of AI safety. Uh, there are a bunch of different kinds of problems in this space. Some of them are policy questions, like what should the legal standards be of various kinds, or what should government regulatory oversight be. And then there's technical questions, and obviously, like mixed in with policy are technical questions as well. Um, and there's a bunch of different directions of AI safety. There's things like fairness, there's things like reliability, there's things like, self-driving cars being safe. And there's sort of, more existential concerns. There's a lot of different work going on here and a lot of interesting directions people are pushing. Um, and um, there's this link and also this QR code are links to job boards for AI safety jobs and AI policy jobs. And a lot of these organizations are very talent constrained. And they'd love to have skilled people like us and our students come work on these problems. All right, that's it for me.
Okay, great. Very interesting talk. Thank you so much. Okay, so yeah, so we have quite a few people watching this video, but um, the we are gonna get the question from the audience first. Anybody having any questions? Feel free to type. We're gonna read on behalf of you. Okay, in the meantime, let me ask some questions. So for the education, your idea to downweight the at-home project homework sounds the great solution. But the downside of this approach is then we should mostly rely on just one or two in-person exams, right? So then maybe the students will feel too much stress for individual exams. Then what could we do to relieve those stress? Maybe more midterms or what should be the solution?
Yeah, so I'll say what we did in our intro algorithms class. We used to only have two exams, like a midterm and a final, and then have a lot of weight on the homework. Well, not a lot, but whatever, some weight on the homework. And we've been increasing the number of in-person exams. Um, it is a grading burden, obviously. Like exams are quite effortful to grade. And so you sort of whatever, you have to pick up that slack somewhere. It's hard. I will say that the last time I taught the class, we did not downweight how much homework was worth to 0. But I know of a couple of other classes at BU that either did pure completion, like did you submit anything at all? One of the classes, yeah, homework was worth, like it was completion only and a fairly trivial percent of the grade. And to give more grading resources to in-person exams and evaluations, they students didn't get every single assignment graded. Students were allowed to ask for like half of their assignments or something they could get feedback on. So that they could use that extra like grading time for the in-person assignments and evaluations and office hours. I haven't figured out how to make the thing I'm about to say work, but something that would clearly be quite good would be if you could run sort of like quizzes every lecture, with, sort of normal attendance kind of forgiveness things of like, only your best performance on X of them count, that are like multiple choice and auto graded. That would be amazing. The issue is if you have students like pulling out laptops and doing something on them, then this once again defeats the whole purpose. Maybe we go back to Scantrons. Scantrons are easier to grade. I, yeah, like I'll say like I still am struggling a bit with like how with the same number of like labor hours do we do something good here? And the other piece of this is unfortunately like homework and take home projects are where a ton of learning happens. Students obviously learn preparing for exams, and also students sometimes learn things on exams, which is a fun piece of like that's cool that happens. But yeah, like I'll say like in my undergrad, homework was really where I learned the most. And it's really sad to be in a world where the incentives around that are just sort of bad. And so, like, you'd love to have the thing that causes the most learning be the thing that's most incentivized. And I just don't know how to do that in our current situation. Um, yeah,
Right.
yeah, it's sort of,
Very
I
difficult
feel
question,
bad
right?
about it.
Yeah,
I don't love
exactly.
it.
Yeah.
Uh, but yeah, like there was so I will say back in the day, like if I had given this talk like 3 years ago, um, I would have talked about the fact that we went through and we gave our homework problems to the AI, and then we like threw out the problems the AI solved perfectly and gave the students the problems the AI didn't solve perfectly. And there were some sections of the class where the AI was in fact sort of good. The problems were sort of structured enough that the AI was good enough that we did just have to give them some that the AI would solve. Um, but I think this just isn't realistic. Uh, I sort of went around and talked to various faculty. This is, theory specific. Like this might be different for architecture, but I'll say for theory specific things, there was only one problem that any faculty, like I sort of, tried to surface problems from faculty that like AI might not be able to solve. And one faculty did in fact surface such a problem. Uh, I haven't tried running through modern LLMs. I sort of suspect it might be able to do it now. But this was like even, like over a year ago, it was already the case that LLMs were good enough that just basically every problem that is appropriate for an undergrad, an LLM can solve. And so, yeah, it just sort of makes it unclear how to help students learn through practice without enforcing that they learn through practice by having them come into class to be evaluated.
Right.
Anyway, sorry, it was a long answer to your question.
No, no, no. So yeah, so that this is definitely really a difficult question. I believe nobody has an ultimate solution. So, but we should have some solution to make motivate at least the students to learn, right? So that to use AI better, then they should have at least some background knowledge, right? But nowadays, all these knowledges can be just easily, right, fed by the AI automatically. So that is the problem. Got it. Okay,
Yeah,
so
like
mm,
for sufficiently advanced, so I guess I'll give one note, which is like for PhD students, these things are much easier. Like if you're teaching a grad class intended for PhD students, you have a couple advantages. One is they're more skilled, and so there's in fact things they can do the AI can't. um,
mm,
uh, it's more plausible, like whatever, it sort of will depend what kind of skills you're trying to teach them to have. But like it's plausible to come up with problems that like maybe the student can't solve by themselves, maybe the AI can't solve by itself, but like the student plus the AI can solve things like that. Um, but also grad students who are taking your grad class are fundamentally like incentive aligned, right? Like you want to teach them so that they can do research in the field, and they want to learn so they can do research in the field, right? Like everybody is like we're all on the same team.
mhm,
Grades tend to
mhm.
be high in grad classes. Like it all works really well. Um, so for grad classes, like my policies tend to be like fairly lax, and I'll like tell students not to use LLMs on particular problems because I think it's useful for their learning to do them by themselves. And on other problems, I'll encourage them to use LLMs just so that they can get a sense of how good LLMs are or aren't. And I'll encourage students, like some of the questions, I'll explicitly ask students to like plug it into an LLM and critique the LLM output. Is it correct? Is it wrong? What's going
Mhm.
on? Um, yeah.
Yeah,
Uh,
that is a good idea to make the students to be critic for the AI answers, right? That sounds right.
yeah, in terms of how to change what students should learn, like one of the changes we've been trying to do in intro algorithms is having more verification type things, like, here's a proof, find the bug kind of things, more sort of skills along those lines. I'll say like it's a little tough to come up with good problems in part because those tend to involve like a lot of text and, you know, students vary in like how quickly they can read and parse large piles of text, and you don't really want to be judging that, right? That's not this like can you read a lot of text fast isn't really the skill we were trying to judge. Anyway, so there's like I'll note there are some problems there, and then of course there's just the issue that like we're hoping to train students to like be successful in like 4 years after their undergrad is over, and also ideally not like have it immediately fail like 1 month after. And that sort of entails at the moment making predictions in some way or another about what the world will look like in 4 years. Um, and software engineering and now CS research as a whole are really changing pretty fast on that time scale, to the point where if I told you or anybody came to you and told you with a lot of confidence what software engineering would look like in 4 years, I think you would, quite reasonably be skeptical of whatever strong claims they were making. Um, yeah, and so it's just a little hard to evaluate. Like if we sort of think about the question of like what the students should be learning, it just is a really hard prediction problem that I don't know. It's tough. Probably verification is part of the answer. Um, I guess with computer architecture in particular, maybe some of your homework assignments are more physical, where students need to like build a circuit.
Mhm.
That seems great. LLMs still don't have hands, so
Right, right. That sounds good, right? Yeah, maybe we are gonna to go back to the more hands-on practices, right?
yeah, like it's a little unclear how in a math class to be like, we're going to force you to we're going to force you to think by having a physical thing you need to do. It sort of makes a little bit less sense. Um, but yeah, it might be something really good that architecture can lean into from a learning perspective.
Great, great.
Sorry, I wish I had like some more, like clean, beautiful, concrete answers to some of this.
No, I think nobody will have those kind of clean, concrete answers. But yeah, it's very good insights, right? Great. So then let's move on a little bit more about your AI safety research. You said you started AI safety research. Would you to share some of the ideas that you were working on?
Yeah, so I was doing consulting with the Alignment Research Center, which is run out of Berkeley. I'm based out of Boston, so this is largely virtual, but I occasionally go to Berkeley. Um, and the Alignment Research Center is specifically like trying to do a sort of theory-oriented approach. I was doing various math with them. Um, uh, the sort of details of the approach are maybe not fully interesting, but the hope was to solve what's called the alignment problem. Um, basically by having, you can think of it as like a formal, the hope was to be able to get something like a formally verifiable interpretation of what models are producing. There's some details here where like the hope is not actually to get something that's equivalent to a proof, like even in the sense of like a randomized proof is a proof. um, but there is a hope of having under some uh, principle of independence, some things that sort of come up uh, under certain kinds of assumptions about how distributions work, being able to give some kind of like verification about what outputs are likely to look like. Um, and a lot of the stuff I did there was impossibility results and a little bit of other kinds of math on specific problems they had. So the alignment problem is sort of where most of my personal interest is in the AI safety world. And there's a lot of interesting work going on there. And unsurprisingly, I'm trying to help with the more theory-oriented stuff because that's where I sort of have a particular background and skills. But there's a lot of really important work that people are trying to do. And I'll say for architecture in particular, um, there's a lot of interest in various kinds of verified hardware and also a lot of interest in like tracking chips and where they are and if authorized users have them. And I think there's a bunch of like practical and engineering and theoretical and just sort of like I think there's a lot of interesting hardware work that is like that policymakers care a lot about, in fact, and that companies care a lot about and that startups are trying to do stuff with. So there's like a whole space there. And then there's also this thing called interpretability, um, which a bunch of companies and labs like have interpretability teams working on. This is sort of more classic ML feel stuff. But the goal is, these models are, fundamentally like trained, not built. And so if you wanted to answer a question, like what's happening when the model is getting a wrong answer, when it's hallucinating, is it lying or is it mistaken? um, it's not immediately obvious how to answer that question, and interpretability works on a variety of problems in this space. And there's been a lot of success actually in being able to sort of look inside models and understand what different parts of the matrices are doing, like what different parts of the weights are doing in these models, and like what computational structures exist within them. It is not by any means perfect. There are a lot of open problems in the space, but like there is a bunch of interesting work happening there on the sort of more applied side. Those are like a couple, this is like a couple of sort of more technical problems that might be of interest to, uh, yeah, people listening to this talk.
Yeah, exactly. So because AI became like another like intelligent entity, like people, right? So we should have definitely some restrictions and policies, right? Like AI ethics, those kind of things we'll need definitely, right? So.
Yeah, I agree. I think yeah, I think there's a big need for a bunch of technical research, a bunch of policy work, a bunch of legal work in this space. And yeah, there are lots of labs, startups, NGOs trying to do things in this space. And yeah, I think like fundamentally, if you have an interest and like you have a set of skills that are sort of computer science related, you're reasonably likely to be able to find a direction that you might be able to provide value to. And I think 80,000 hours is sort of a good starting place just because they have this job board that a lot of these jobs get posted to.
Great, great. Yes, you're right. That is very promising and motivated so that so many jobs are there, right? So
Yeah,
yes, right.
yeah.
Exactly. Okay. Okay, so then in terms of time, maybe we should conclude this
Okay.
talk right now. So
All right.
once again, thank you so much for your insightful talk. And then hopefully you have a beautiful baby pretty soon. And then
Thank you.
see you again. Yeah.
All right. Thank you so much. And thank you for having me.
Yeah, sure, of course. We are excited. We are honored to have you. Thank you.
I'm honored to get to talk to you all. Yeah, everything that's going on.
Great. Okay.
All right.
Okay, the stream is ended.